We should be recording now. We'll see whether this works. This is me sort of playing with my technology. So this is an SOS workshop about how do you study for science classes. And students sometimes are struggling when they come because if they've not been taking science classes or if they're just coming straight from high school, they don't really understand what we expect in the sciences. Here, this is the fun part. They don't really understand what we expect in the sciences. And they kind of think we're crazy, right? With the expectations that we have. Here, let me change pointers here. And the workload is different. And so we get this comment a lot. You know, do you think this is the only class we've got? Well, no, but we understand that the classes we're teaching require more than some other classes. So we're going to talk about what those experts are. So first, one of the things I say every time I'm here, has anybody seen me speak before? You've seen me speak, so this is going to be familiar to you. The first thing we've got to realize is how being a college student is different than being a high school student. Because for all of you, you wouldn't hear if you weren't at least semi-successful at being a high school student. Some of those things translate, some of them don't. But the biggest difference has to do with the way and where you learn. In high school, in most states, they require 180 hours of classroom teaching time, right? You got to take 180 hours of coursework, okay? Now, if you assume you're in class about an hour a day, that means you've got 180 hours to learn some volume of material, right? But in college, we assume we're going to do as much in a year as you did in that high school, or I'm sorry, we're going to do as much in a semester as you did in that high school class in a year, okay? So that number, 180, is important because you had 180 hours of time in front of your teacher of a variety of activities to learn a given volume of information, right? When you get to college, we're going to learn that same volume of information in a semester. Now, in that college classroom, you may have only 4 hours of instruction per week, sometimes only 3, but I'm going to use 4, right? And so in a 15-week semester, that gives you 60 hours, right, in class. Now note the difference. 60 hours, 180 hours. Do you notice a slight discrepancy in that learning time there, right? That's important. Okay? Now, did any of your high school teachers, counselors tell you, when you go to college, you're going to have to spend 2 hours outside of class studying for every hour inside of class? Did they tell you that? Yeah, I'm getting a lot of no's. That was something we were all told. I got to go bat your high school teachers around because they're not telling you this stuff. But look, right? We just said you've got 180 hours to learn some volume of information in high school. You've only got 60 hours in class to learn that same volume of information in college, meaning we got a slight 120-hour discrepancy in learning time, right? So if we take that 120 hours discrepancy, learning time you've got to make up outside of class, divide it by how much time you actually have in class, what do we get? 120 divided by 60 is that magic number of 2 that your high school teachers and counselors were supposed to tell you that you were supposed to study outside of class for every hour in class. And I'm telling you that because in difficult courses like science courses, that number is really important, right? That number gets to be valuable. Okay? Now, what are we trying to accomplish in class as a college professor? Okay, in a college class, the instructor is going to present the material at a level that the average student that stayed awake and paid attention Now here's the important part. We'll need to work between 1 and 2 hours after class to understand everything done in class that day. So our goal is not to make you understand in class. Our goal is to give you hints about what you're supposed to work on in that 1 to 2 hours outside of class that you're going to spend. Right? We're not supposed to make it crystal clear in class. We're supposed to go faster than you can keep up, but just fast enough that it takes you about 2 hours to figure out what we did in a class that day. Right? That's different than it was in high school. In high school, your teacher wanted you to understand when you left the room. In college, we want you confused when you leave the room. But only confused enough that it takes you a couple of hours to figure it out before you come back to the next class. Right? It's a delicate balance of how confused you're supposed to be. Right? If you didn't leave confused, we didn't stretch your brains enough. Right? Okay, so if we're going to go that fast, and in the science classes we assume more than probably any other area of the university that this is the way students are going to operate. If we're going to go that fast, how do you survive? Right? Well, first, if we're going to go a little faster than you can keep up, the best way you can keep up is to know where we're going before we start. So, first, come in having read at least enough to know what the words are. Right? That's kind of important, especially in a class like the sciences, where the scientific language can become jargon outside of normal usage. Right? If you don't know the words we're using, you're going to be more confused, which means it's more likely that it's going to take you more than the 2 hours after class to catch up. So if you've at least read well enough so that you know what words we're going to use, right? And you know what kinds of problems we're going to solve, even if you can't solve them yet, then you're ready to hear the answers when we solve them. Okay? And so that means you're ahead of where we are instead of constantly being behind. Right? Students tell me all the time. I say, did you read the material? And they'll say, oh no, when I read the book it doesn't make any sense. But after I've heard you talk about it, and then when I go back and read it, it makes much more sense. Right? I see the knowing look right there, right? You know what I hear? The second time I hear it, it makes more sense than the first time I hear it. Isn't that what they're saying? But what is the most valuable time to hear it? In class, right? Isn't that the time when you've got someone in front of you telling you what's important? And shouldn't you be most ready to understand it at that time instead of after that time? Right? So if you read it, even if you don't understand everything you read, it's going to make that in-class time, more of that stuff where we're going a little too fast, where we're trying to stretch your mind, more of that is going to make sense if you've prepared for that ahead. You're not supposed to understand it all the first time you read it. You're supposed to understand more of it the second time you encounter it. It's better if that second time is in class instead of after class when you don't have us there to ask us questions, to clarify, to tell you what's important. Does that make sense? Okay, so that means you need to prepare for lecture before lecture starts. One of the things that my students have started doing is starting their lecture notes before lecture starts. When they're reading, they're doing things like writing down that vocabulary that they're pretty sure I'm going to use when I get to that point. Getting some important ideas, important structures, taking some notes about problems, so that when I talk about those things, instead of having to spend time writing down every word, part of the time all they're doing is going, yep, he talked about that. Yep, he talked about that. Right? You can check things off. You can add little notes of clarification without having to write every word down and then go back and try to catch up later. Okay? So, once you get to lecture, listen intently. Now, what does listen intently mean? No texting. I don't know how many times I have to tell students to put their phones away while I'm in the middle of saying something really, really important, right? Because they're texting. But every time they're looking at their phone texting, what are they not doing? Listening. Yeah, they're not listening, which means they're not catching the important things I'm trying to tell them, right? So when you get to lecture, you got to pay attention because everything we say has a message. And mostly that message is this one. I think this is important enough to talk about it, so it's probably important enough for the test. So you don't have to ask, is this going to be on the test? Because if we're talking about it, the answer is yes, it could be on the test. Right? The other thing is write. Write and write and write. Right? Learn to get an automatic connection between your ears and your hand so that your hand is writing down whatever your ears are hearing while you're continuing to process what is going on. I think skills-wise, the biggest change I've seen in the 23 years I've been teaching is in the ability of students to write while they're listening. I catch more and more students who get caught up listening but can't write and keep up. I blame the loss of real teaching in cursive because that's what cursive is about. Keeping your pen on the paper so that you can, with as little fatigue as possible, continue to write. So you need to be able to relax, you need to be able to listen, and you need to be able to write quickly while you think. Okay? Excuse me. So, listen critically, right? You have to continue to think and be critical about what we are saying, right? Ask questions of what we're doing. And every once in a while, we're going to ask you to think about something. And when we ask you to think about something, that means really stop and concentrate on it. Because if we want you to stop and think, then we're saying this is an important idea, and it's one that's difficult. It's not one that you can comprehend when you're distracted. But then you have to remember what you thought about, and sometime go down and get that idea in your notes so that you can think about it again later. Now, remember, you're not supposed to understand everything in lecture. We're going to go faster than you can keep up. Right? Your brain will feel like it is scrambling. You should be tired at the end of one of our classes because your brain has worked hard to keep up. Okay? What we're trying to do is tell you the things you need to work to understand before you come back to the next class. Right? We assume that you do that work and you are caught up with where we were when you show up for the next class. Okay? That's an important assumption for us. Right? So, once lecture is over, go back. Look at the chicken scratches that are your notes, because they will be. Right? If you're processing difficult information and writing quickly as we go and stopping periodically when we ask you to think and then trying to scribble down enough of a note that you know what we ask you to think about so you can do it again later, your notes at the end of an hour are going to be a mess. And they should be. Right? They're going to be all over the place. So one of the things you have to do is go back and take the cryptic little abbreviations, and you should learn how to do that, and the the scribbles that you can't quite read, and all of that, and make it make sense. Right? And then, so you have to make the part you got make sense. And then it's best if you compare what you got with what somebody else got. Because everyone is going to see, hear, record slightly different things. And so compare what you got, what somebody else got, and then go back and also look at the book and compare what you got, what somebody else got, and what the book got to see what's the same, what's different. All right? Because we have something fluttery going across our screen. Because, right, this is important because my students found out something last week. They came in and they were working a series of problems and they were sure they had the math right. Right? They were sure they had the math right. But in the end, they were getting the wrong answer. And this was in an online homework system. So when they submitted the wrong answer, it would dock them 10% of the available points and tell them to go try again. Well, they were sure they were using the system right. They were sure they were doing their calculations right. They were sure they were using the numbers I had given them in their notes. What was the problem? I messed up. There were two numbers that I gave them, but I gave them to them backwards. I reversed the two numbers. Two constants. Easy to do when I'm pulling them from my memory when I'm lecturing. But what did they not do? They didn't check the book. They didn't see if Dr. Burnell screwed up by giving them the numbers backwards. Right? They didn't compare their notes to what the book said, and so they were getting the wrong answer. Right? That happens sometimes, and the only way to know that is check the book. Okay? So, whether you have an instructor that gives quizzes or not, and I don't, but some do, you've got to study like you're going to have a quiz every day. Because even if I don't give my students a quiz, I am lecturing the next time, assuming they understand every idea I talked about the last time. And if they don't, what happens? They get behind because they don't understand. If they don't understand an old idea, they're not going to understand the new idea as well. Right? So now they're 2 days behind. And if they don't fix that, then what happens the third day? They get even farther behind. And now, right, they're in, what did the old commercial say? You're in deep snow now, Norski Fibber. Right? So, by the time you come back to the next class, you either know and understand what you talked about in the last class, or you start the next class with a question, right? The first couple of minutes of your very next class period are when you cover things you didn't understand in the previous period. One of the things I believe in strongly is I refuse to devote a whole class period to reviewing for a test. Because I've given them an opportunity every day to review stuff from the previous day. If we get to the day before the test and they're asking me questions about stuff that we did 3 weeks ago, I'm not going to be able to fix that in an hour the day before the test. Because they didn't understand something 3 weeks ago, which means they didn't understand a lot of what we did every day in between those periods. Right? Okay. Now, things are a little slow. Come on. Catch up. Did I lose my connection? Now we're back in business. Okay. More hints. Right? Don't rely too much on experts. Right? Now, this comes from a story. I had a student who was a pre-pharmacy student and should be graduating from pharmacy school now. So ultimately, she was successful. So I don't have a problem sharing this story. But she wanted to get into pharmacy school early. She wanted to get into pharmacy school after her sophomore year, not earn a degree here, go straight to pharmacy school. And so she knew she had to do really well in organic chemistry, which is one of the most difficult courses we teach, right? There's a huge volume of information. So she and a friend studied for hours and hours and hours, and they would talk about the material and they would work really hard. And at midterm, she had an A-, right? Well, she wanted better than an A-. So she went and got a tutor, a pharmacy student from Butler that her mother knew from something. You know, it was one of those kinds of family connections. And apparently this kid was really good with his organic chemistry, and he sat and explained all these reactions to her through the second half of the semester, and she was all excited because he knew so much organic chemistry. And we got to the end of the semester, and do you know what she got? A B+. Her grade went down. She had this wonderful tutor, and her grade went down. Why? Right? Because she had substituted the work he did to understand those reactions for her own work, right? She had been doing that work in the first half of the semester to figure these things out on her own. But as soon as she had this expert, she stopped doing the work in her own head to figure them out and have them make sense for her. She substituted his expertise for her own, right? These are hard ideas. Even if someone else understands them, they're ideas you have to struggle with yourself, right? And so we see this all the time. Study guides and solutions manuals. Instead of working problems on their own, students will pull out the study guide or the solutions manual and say, well, yeah, that makes sense, and that step 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 makes sense. So I must understand how to work that problem. But then what do they never do? Go work the problem themselves to see if they can do it without the help, right? At some point, right, you have to do that work on your own, right? Same thing, right? Tutors already know the material. They make it sound easy and straightforward. Right? They're juniors and seniors. They already were successful at general chemistry. They already were successful at general biology. They already passed anatomy and physiology. Right? They already did that work to understand. Don't let their understanding cloud the work you have to do to understand yourself. And one of the most important things is, be wary if we make it sound easy. Right? Just because when we explain it, it sounds like it makes sense, don't trust that, right? For a couple of reasons. One, what I've already been talking about. And see, how long have I been teaching? I've been teaching here as a full-time faculty member for 23 years. I've been teaching at the college level for 26. I am a professional explainer. I know how to make it sound good, right? I know my point is to make it sound easy enough that I don't scare you away from the idea so you'll go do the work to learn it, right? But don't be lulled into a false sense of security because I made it sound that easy, right? The ideas are not that easy, and it takes work to approach them. So in the end, you have to do your own work of learning. That's the most important part, right? These are not easy ideas. Okay? Now, this is important, and I see this all the time. Make sure you're prepared for classes before you take the class. We have a number of students that struggle with prerequisite expectations, right? You know, I like to say more students don't get into medical school because they can't do math than for any other reason, right? Right? Whatever the prerequisite is, in science classes especially, we hold to that prerequisite. If the prerequisite is mathematics proficiency, we don't just mean, you know, can you add 1 and 1 and get 2 most of the time? Right? We expect that you can really do your math through algebra. Right? That's what we consider mathematics proficiency. That you're actually pretty good up through algebra. Okay? So if you're not, then make sure you take care of that before you get into one of the science classes and find yourself in trouble because of a skill you could have addressed. If you know, there is a biology class that you're going to take and they have a prerequisite of, you know, say you're supposed to pass, was it biology 103 is physiology, right? That's anatomy. 104 is physiology. And I think 104 is prerequisite for you to take the biology 209, which is the clinical micro if you're a nursing student. Is that true? And so if they say you need, you know, biology 104 with a C or better to take clinical micro, that doesn't mean C minus, right? It means they expect you to know your stuff from biology 104 before you take clinical micro. They're going to expect you to know things from that course. Okay? We hold students to those prerequisites, right? Now, this is something else, and it has to do with a lot of our students that are taking our science classes. We have a lot of students taking science classes, not because they want to be scientists, but because they want to be some kind of professional. They want to be a nurse, they want to be a physical therapist, they want to be an occupational therapist, they want to be a pharmacist, they want to go to optometry school, something like that, right? Now, so in college, we're looking at 2 things in every one of our courses. It's not just about that course. The first thing is, we're looking at the next course in the curriculum that expects that you know something from this course. So our first question is, do you know the things from this course that you need from the next course you might take in the sequence? Right? And the other thing we're looking at is professional schools, graduate schools, employers. What do they expect you to know? Right? That's our standard. If I'm teaching a Chem 104 class, which is the nursing prerequisite class, and no one performs well enough that I would trust them to take care of me or my children if they became a nurse, it is my responsibility to give all of them D's or worse. Right? It's not about what the class is. It's about what the standard is for whatever those students want to do. The standard for performance comes from outside of these classes set by professional schools, graduate schools, and employers. Okay? Homework. One of the things we look for, right, is, and it relates to the expert thing, we look for independent mastery of the material. One of the reasons why I don't take up a lot of homework is, if I get a homework assignment, how do I know it's your work? I don't, right? What's the only time I know I'm getting your work? Test day, right? So, we're assuming that students are constantly doing whatever homework they need to do, right? Because it's all about, what does it take you to learn the material? Right? One of the things I found in assigning homework, if I assign 6 problems a week, how many problems will the average student do? No, the good students will do 6. How many will the average student do? 4, 3, none, right? If I assign 10, how many will they do? Yeah, somewhere between 6 and 10. But what if it takes you 15 problems of a type to learn how to do that? No, right, exactly. But if I assign 10, how many will everybody do? 10, right? So it really is more about what do you need to make sure you are confident with your independent mastery of the material. That's what's important. Okay? Now, the level of understanding that we expect, right? In high school, learning is mostly at what I call the operational level. I teach chemistry, and so most of the time, what they do is if you can match the proper equation and plug in the right numbers, exactly like the teacher did it on the board, probably you can get an acceptable grade. You may not get an A, but they'll do enough of that you can pass, right? At the college level, because we're talking about people wanting to do these important professions, who need to be independent thinkers, the learning has to be at the conceptual level. You have to really understand the material in a way that you can use it, apply it, not just in one situation, but in a variety of situations. Okay? So let me give you an example. This is a high school level temperature conversion problem. This is very similar to what my son did last year in his first year of chemistry. So they gave a problem. They gave a temperature, and then they gave a formula that ended up with units that were the same as the units that they wanted the answer to be in. And all you have to do is take that number and stick it in there and not screw up your math and get the right answer. Right? Isn't that a fair? If any of you took high school chemistry, isn't that something that you might have been asked to do? Now, you want to see one of my temperature conversion problems on a chemistry test? You probably don't. Okay, so there's my problem. An alien spacecraft crashes in your backyard. While waiting for the proper authorities to arrive, because of course you would call the proper authorities, you also would converse with that said alien about normal body temperatures, a daily topic of conversation with alien life forms, right? So, the alien says that her normal body temperature is 335 degrees on her alien scale. You don't know how to convert that, again, to tell the proper authorities some important bit of scientific information about the alien species. So, she also happens to tell you that on her temperature scale, water freezes at 200 degrees and boils at 470 degrees. So what is her body temperature in degrees Fahrenheit? This is a problem that I give in various forms. Right? So what do you have to do? Well, first you have to have an understanding of temperature scales and the equivalence of temperature scales. And realize that on the Fahrenheit scale, water boils at 212 and water freezes at 32. And so you can use that to say there is 180 degrees difference there. And on the alien temperature scale, water boils at 470 degrees, water freezes at 200 degrees, and so that difference is 270 degrees. So 180 degrees on the Fahrenheit scale is equal to 270 degrees on the alien scale. Now we've got a relationship between the scales that we can use, right? So there's that. So we've got that relationship we can use. Now we're only partway done. This one takes 2 pages. So she said her temperature was 335 degrees on the alien scale. the freezing point of water was 200 degrees on her scale, meaning she's 135 degrees above the temperature at which water freezes, which we're using as a reference temperature. That 135 degrees on the alien scale, we can use that relationship that we found, right? Which ends up being 2 degrees Fahrenheit for every 3 degrees on the alien scale, and find out that in Fahrenheit, her temperature is 90 degrees Fahrenheit above the freezing point of water. But what's the freezing point of water? So we're 90 degrees above 32. So her temperature is 122 degrees Fahrenheit. What does that make her? Officially hot. Okay? So, if you're studying for courses that are based on problems, you got to do a few problems every day, right? So if you're in a chemistry class, in a physics class, you got to do a little bit every day. Work a few problems all the time. Every day you've got to do a few new problems, right? Whatever you worked on in the most recent lecture, understanding those kinds of problems that were presented there, right? Always throw in a few review problems, right? Don't get behind on that. And also, write everything out. Units are important, okay? Now, I'm noticing by the clock that I'm running out of time, so I'm going to stop here and ask if you have any questions. I was asked to make this information available, so outside of my presentation, I'm going to finish my complete set of notes so that I can finish the story. But if things seem different, it's because now I'm not talking in front of a group for the rest of this video. So, studying for a science class, that's more about information. One of the things we have to do, and one of the things that students struggle with in science classes, is understanding the language, right? The language of science is very important, okay? You have to know precise definitions. Language in science is really about making communication more efficient. If you've ever read anything written by the early scientists, it's very difficult to get through because they have to express these complex scientific relationships in what was then the regular language of use. And so it gets very cumbersome when you read Isaac Newton or Antoine Lavoisier in whatever language you're reading to try to pick out the meaning, because the ideas are so complex that the language couldn't handle it. And so in order to make scientific communication efficient, in order to carry the weight of what it took someone like Isaac Newton 15 words to say, we've learned to say it in one. And if you don't understand the power of that one word, then you're missing a big part of the story. So one of the things you have to do in science is learn the language. The words we use are important. And really this is a big difference between high school and college. In high school, one of the things they try to do very often is to get you to express difficult ideas in common language. It's a way to see if you understand the complex idea. In college, we almost reverse that. Instead of expressing a complex idea with a bunch of simple words, we expect you to express your understanding by expressing a complex idea, properly using the scientific term in context. And so that changes the way you have to think about knowing the language. Okay? The other thing that we find is students just try to memorize their notes, right? And the big thing is don't, right? It's not about memorization and regurgitation. You have to really understand the information so that you could explain it to someone else. Now, first, this gets back to this idea of language. The first person you want to explain it to is someone else who doesn't understand, and so that would be the common language idea, right? Then you want to study it so you could explain the same information to the author of the textbook or to your instructor, using language they would understand. So, assume that we'll ask what the information means, not just what the information is. Okay, so when you ask us a question, you have to give your instructor enough information to help you. A student brought this problem to my office, and this is what they had written on their page, right? And I went through and I was, just trying to look at their numbers and look, 171 divided by 71, yeah, I can see that where that was about 2.08. And 32 divided by 8, yeah, that's going to be about 4, okay. 1 over 300, yeah, I can see that that's about 0.003, okay. So far the math looks good. And then they divided both sides by 395, that looks good. And then they added that across, that looks good. And that was that. And then, okay, so math-wise, that looked good, right? If you follow through this math, all the math looks correct. And in truth, it is. But then I looked closer, and this is what I realized. That if you included the units, here was the problem. Look, here we have something in kilojoules per mole. Here we're dividing it by something in joules per mole. Right? That was incorrect. Once we realized that with full units in there, we needed to convert our kilojoules to joules. And then we could do our division by joules per mole K. Then the answer ended up being correct. Okay? So what the student showed me was not what I needed to see in order to help that student. I was getting an incomplete picture. So, if you're studying for a science class that's about the information, this would be something like a biology class, sometimes something like an environmental science class where there's fewer problems and more concepts and information to learn. Okay? One of the things you'll find is that lecturers often approach a subject by presenting the big picture first. Okay? Explaining the what and the why of the subject, right? Then presenting the details later. Okay? So, in your studying, you have to sort of get both things. Make sure you understand the big picture. Why is this information important? You have to get that part, or the details don't make sense. So you get the big picture, and then you study the details. Okay? And the details should fill out the big picture so that that makes more sense. That's the way you have to approach an information-based science class. Okay? Now, another thing, and I've seen students do this over and over and over again. Do not cram for exams. Right? As a rule, you should start studying for a biology exam a minimum of 2 weeks prior to the exam. And actually, if you go back through everything I've said, every class is like studying for the exam before the next class. Okay? You should start reviewing your notes on a daily basis. Okay? You want to gradually learn the information over time. Right? You do not want to be in a position of having to cram a lot of information in your brain in a short time. Your brain gets tired and your brain can't learn that way. It's much easier if you do it a little bit at a time. You can almost think about studying for a class, an information class like this, like weightlifting for your brain. If you want your muscles to get stronger, you don't start by, lifting twice as much as you've ever lifted before. You do a little bit at a time, you get a little better, and you gain strength slowly over time. Your brain learns in much the same way, and you have to train it in much the same way. You exercise it a little bit at a time, it gets stronger gradually, and then you don't have to cram information in at the last minute. Now, another thing that we have to remember in science classes, right? Science classes are about getting better, right? And one of the things that students often have trouble remembering is that our feedback is not personal. Everything we say to you is really about trying to help you get better, okay? That's what we want, right? And every bit of feedback we give you is something that we think you should act on. If we score your test problems and they are less than 100%, we're telling you that there's something there you need to go back and correct, right? If we make comments on homework, what we're trying to do is tell you how to correct something so that later, when it's really important on test day, you get it right. Even when we're interacting in class, whether we're talking to you or whether we're talking to another student, if we're correcting something, you should pay attention to that correction, right? We expect you to use our feedback to get better. That's what we all want as instructors. We want you to get better, right? It's about you getting better. And I don't know how many students I've had. I've been teaching for a long time now. I don't know how many students I've had that will do not as well as they want in my class. And then I will see them someplace else on campus. And I will talk to them about their athletics or their music or their art because I'm interested in them. And they're surprised. They think that the grade I gave them had something to do with whether I liked them. And that's not it at all. It's all about me trying to tell students what they need to do to get better. I hope what I've posted here is helpful. I would appreciate comments, so thank you very much for your time.